Since many complex and functional electronic products are designed today that use IC in their design, those interested in this field should know what IC is and what it is used for. The application of these parts is so wide that it can be safely said that most of our daily electronic devices are composed of ICs. Familiarity with ICs allows us to have a good view of electronic circuits. In this video, you will get to know the types of ICs and get useful information about these important electronic parts. Join us to have a good experience with IC in the world of progress and technology. If you have watched the educational videos on my channel and are familiar with resistors, capacitors, diodes, and transistors, you will understand IC better. ICs are used in most electronic circuits today, such as refrigerators, televisions, washing machines, and smartphones. The early production of ICs revolutionized electronic circuits and equipment. Because by using these parts, electronic circuits can be made with dimensions tens of times smaller than in the past. In the manufacture of ICs, the design and manufacture of transistors is easier than other circuit elements. As a result, the effort is to make all the components of these circuits transistorized. What does IC stand for?
Abbreviated English term for integrated circuit, which is abbreviated as IC. IC is sometimes called microchip.
IC manufacturing steps.
IC manufacturing requires a lot of science and technology, and the full explanation of its implementation steps will be out of the practical space of this video. That's why we explain the main steps of this process in a very brief way. First, IC circuit design and simulation is done by electronic engineers. They use software and simulation tools to analyze circuit performance and ensure the correct operation of the circuit in question. IC manufacturing is done in a space called a clean room, so that the environmental conditions affecting the manufacturing of the part are under control.
1. Wafer production.
The first step is to produce a large, thin, circular slice of semiconductor material, usually silicon, called a wafer.
2. Photolithography.
In this step, a layer of light-sensitive material is placed on the surface of the wafer. A light mask layer with a special pattern is placed on it, and then ultraviolet light is shone on its surface. The parts that do not have a light mask are burned.
3. Engraving.
The created wafer is placed in chemicals so that the parts that are not needed are dissolved in them.
For adding impurity.
In this step, impurity is added to the existing semiconductor materials to create areas with different electric charges.
5. Deposition process.
Using different methods, a thin layer of the desired material is placed on the surface of the wafer.
6. A metal cover.
In this step, physical connections are made between different parts.
7. Health test.
Finally, the finished wafers are tested to make sure its correct operation.
8. Packaging.
In the last stage, The manufactured ICs are separated and each is packaged in its own package with pins connected to the internal circuit.
Types of ICs. Types of ICs. Now that we understand what IC is, we will examine its types and categories that are considered for this part. These circuits have different types that are classified based on the way of making, application, and technology of microchips. IC types based on application. Analog ICs. These types of ICs are used for analog controls such as audio, video, voltage, and current. They are usually used in various filter circuits, amplifiers, and converters. Digital ICs. These types of ICs are used to process and control digital signals, 0 and 1. They include logic circuits, and, OR, NOT, etc., and microcontrollers. Combined ICs, analog digital. In this type of ICs, analog and digital parts are placed together on one circuit. It has the ability to process both types of signals. For example, hybrid ICs can be called digital to analog conversion circuits or analog to digital conversion circuits. Sensor ICs. These types of ICs are used to measure and detect physical information such as temperature, humidity, pressure, etc. Power ICs. These types of ICs are used to manage and control electric power, such as DC-DC converter ICs and power amplifier ICs. Memory ICs. These types of ICs are used to store and maintain information digitally. It is used like RAM, ROM, and flash memory. Also, ICs can be divided into analog and digital based on the classification of electronic components inside a chip. A. ASIC Application-Specific Integrated Circuit. ICs that are designed and manufactured for a specific application and desired properties. B. FPGA, Field Programmable Gate Array. ICs that are pre-designed and can be reprogrammed to perform different functions. Types of ICs according to microchip technology. According to the microchip technology, generally nanometer, ICs are divided into different categories. Each of these technologies usually consists of a microchip with a high number of transistors and a small size. Some of the microchip technologies are 180 nanometers technology. This technology was commonly used in the 2000s and was usually used to make old ICs. (130 nanometers technology). This technology was used from the beginning of the 2000s to the end of the 2000s and was widely used in the satellite, mobile and portable device industries. 90 nanometers technology. This technology was introduced in the 2000s as a more advanced technology and was widely used in this decade. This technology has lower energy consumption, smaller size, and higher speed. 65 nanometers technology. This technology became widely used in the 2010s, and more advanced ICs and some microprocessors were built using this technology. 45 nanometers and 32 nanometers technology. These technologies were used from 2010 to 2020 and made much more advanced ICs with many capabilities. 22 nanometers and 14 nanometers technology. These technologies have been used since 2010 and have created very advanced ICs with very high capabilities. 5 nanometers and 3 nanometers technology. These technologies are currently the latest and most advanced IC manufacturing technologies that offer very high capabilities and smaller size.